All right, we're still going on in our Pythagorean theorem and volume unit, so make sure you jot that down. Today we're actually going to get into the Pythagorean theorem and what it is. So take a look. The Pythagorean theorem, let's talk about the name before we get into the math. Pythagorean refers to the gentleman who is given credit for this idea. His name was Pythagoras. Okay, he was a Greek, and he founded a school. And his group, the Pythagoreans, they had all kinds of strange and weird beliefs, but one of them was that he believed that numbers ruled everything, specifically whole numbers or fractions made of whole numbers. Nothing else existed. And one of the things that Pythagoras taught was mathematics. And this theorem that we're going to talk about, by the way, a theorem is simply an idea that needs proof. Proof. Okay, so the Pythagorean theorem is his idea about right triangles. Now, before we get into it, again, the actual math, let's talk about a situation where we could use the Pythagorean theorem. All right, so for example, let's say you bought a house, all right, and not just any house. This house has a pool. So we'll add some water. Watch out, Miss Hahn. Here's my artistic ability at its finest. And let's say not only do you buy this new house and not only do you have this pool, but you want to hang streamers from one corner of the pool all the way to the other. Now, not only have you bought this house, not only have you bought this house with a pool, and not only are you going to have a party with streamers running across like this, you've got a big pool. I mean, a huge pool. As a matter of fact, if we were to measure along one edge, it would be 300 feet long on this side and 400 feet long on this side. I mean, this isn't a pool. This is a man-made pond. All right? Huge thing. Well, here's the question. How in the world would you know how long the streamers or banner or whatever you want to put all the way from one corner to the other? How would you know how long that would be? Well, notice in this case, since our situation is over water, it's going to be very difficult for us to measure from one spot to another. So if you're thinking, well, I'd use a tape measure. Well, most tape measures don't measure much beyond 25 to 50 feet, so you would have to do it in sections while in the pool. And for all we know, maybe this end's the deep end, and you wouldn't even been able to touch bottom. Other students that I've shown this problem to said, well, I would stretch a rope from one side to another. But let's say this is you, and here's the pool, and here's your friend on the other side, and you're trying to stretch a rope that kind of distance. The rope would sag in the middle, making it longer than the actual distance across. So in situations like this, where making what we call a direct measurement is impossible, we're going to use an idea called indirect measurement. Meaning I'm not going to actually measure this distance. I'm going to use other measurements to help me figure it out. So in this case, the measurements that I would use is this side of the pool, which is on ground, pretty easy to measure. And on this side of the pool, again, also on the ground and very easy to measure. The Pythagorean theorem, so this idea that Pythagoras came up with that needs proof, deals with right triangles, okay? In other words, one of the angles has to be a right angle. Now let's talk about right triangles. The two shorter sides make up the right angle. We call these sides legs. So here's a leg, here's a leg. All right, both of them are legs of the triangle. This longest side, all right, this side here, we call this side, make sure you can see it, we call this side the hypotenuse. And that's real fancy math speak for the longest side of a right triangle. Okay? Now, here's what Pythagoras figured out. There is a connection between the legs of a right triangle and its hypotenuse. Now, In order to make this easier, okay, for us to talk about his idea, instead of talking about a leg or hypotenuse, we're going to name the sides. We'll name the two sides that make up the right angle A and B, and we'll call the hypotenuse side C, all right, just to make things easy. All right. Now, as it so happens, I've got a triangle done up, and here's what I want to do. I'm going to take this right triangle, and we're going to use some square blocks that I've got here, and we're going to measure this triangle. Well, and we'll see what happens. So take a look. I'm going to grab my green ones here, and I'm going to measure side A and just see how long it is. Okay. Each one of these blocks is 1 inch long. So I'm going to go here, and let's see. We'll start lining it up. So there's 1, there's 2, 3. So it looks like side A is about 3 inches long. Okay, so we'll keep that in mind. Let's take a look at side B. Let's see if we can figure out how long it is. Let's see, there's 2. Let's see, there's 2 more. So it looks like it's about 4 inches long. All right. Now, here's what Pythagoras found out hundreds and hundreds of years ago. If I take the distance of side A, so we said that it was 3 inches, all right? And if I were to square it, in other words, if I were to take 3 times 3, so here's what I'm going to do. I'm going to grab some more tiles, and I'm going to make this 3 by 3. So 3 inches across this side, 3 inches down this side. How many square inches do I have? Well, if I add them up, 1, 2, 3, 4, 5, 6, 7, 8, there's 9. And remember, 3 times 3, or 3 squared, is 9. Keep that in mind. All right? Let's look at side B. We said it was 4 across. As a matter of fact, I've got some other tiles. Let's square this side. Let's see what happens. So there's 4 more. 4 more still. Last but not least, 1, 2, 3, 4. There we go. Let's see if I can get them all somewhat squared up there. Now, we said that side B, we measured and we found it to be 4 inches in length. And Pythagoras said, you know what? I need to take this side and find its square as well. So we've got 4 inches on one side. We've got another 4 inches up here. 4 times 4, right, or 4 squared is 16. So I want you to see this. Okay, you ready? I'm going to take all of the squares. So I've got 16 yellow and 9 green. Watch what happens with side C. All right, give me a second and I'll show you. Watch what happens with side C. And for all of you Packers fans or John Deere fans out there, I did this just for you. Out of green tiles now, so that checkerboard's going to have to stop. We'll just fill in the rest with the yellow. Take a look. This side is 5 inches long. And now I've got yet another square. 5 by 5. 5 by 5, or 5 squared, is 25. Let's put that all together. Move that out of the way. We said side A was 3, side B ended up being 4, and side C was 5. I took side A and squared it and got 9. So A squared. We said A was 3 inches and we squared it. Hold on to that. Side B. We said we took side B and squared it. 4 squared. We just added them all together, right? That's how we got all this. So we just added that all together, and we got 5 by 5, or 5 squared. 9, 16, make 25. This is called the Pythagorean theorem. If I know two sides of a right triangle, I can take their distances, square them, add them together, and they will be the same as the square of that last side. This was huge. In the ancient world, this was known all over. In Egypt, they would take rope and they would tie knots in the rope. And they would put a person here, and a person here, and a person here. And every time the Nile River would flood, all the boundary markers in the fields would wash away. But they would send 3 men out into the field, 3 sections of rope here, 4 sections of rope here, and 5 sections of rope here. To form nice right angles, they'd pull the rope tight, and then they could mark off these nice, neat boundary markers using right angles. The Babylonians knew about this, and they had tablets of numbers of different sides of right triangles. But it wasn't until Pythagoras that he wrote this idea down and proved it very much like what I just showed you by making the squares, drawing it out, and showing how it works. So let's write this down. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are legs of a right triangle and c is the hypotenuse. Let's take this idea and go back to your situation. So you bought the mansion, you've got this pool that's nothing short of gigantic. Take a look. Here is your right triangle. We've got one leg, so there's side A. We've got another leg, that's side B. And the distance that you're wanting to find to hang your streamers is the hypotenuse, side C. So let's use the Pythagorean theorem and see what we can work out. So side A, so again, A squared is 300. So we're going to take 300 and square it. Side B, we add it to B squared. So in this case, side B is 400. 400 squared. And according to the theorem, we end up with the hypotenuse squared. Or in this case, well, we don't know that distance yet. Let's see if we can figure it out. So if you're not sure what 300 squared is, remember your calculator can do it. So 300, and there's the x squared. So that gives me 90,000. So let's write that down, 90,000. Let's do 400 squared. Notice that's 160,000. There we go. And we still don't know c squared, but we're getting closer. Let's add these together. So 160,000, add 90,000. That gives me 250,000. Now, the other day, we talked about how do we solve equations with squares or square roots. Well, notice here's a square. Remember, we said that if we have something squared, we undo it with a square root. So I'm going to take the square root of this side and the square root of this side. Notice we said squares and square roots undo each other, so that's just side C. Let's take the square root of what we've got. So we do that by second, our x squared button, remember that's the square root, 250,000. Let's see what we get. 500. So the distance across your gigantic swimming pool is 500 feet. Hopefully this looks familiar. Notice our original triangle that we used. was 3 inches by 4 inches by 5 inches. All I did was multiply those by 100 to get this next example. It works. Let's try another one. Let's try an example like this. Suppose I know I've got a triangle, and let's make the numbers a little smaller. Let's suppose our triangle, and there's our right angle. Let's suppose one side is 5, and the other side is 12, and I don't know, let's do miles. Maybe we're talking about a really big triangle drawn really small. Okay, so 5 miles in one direction, 12 miles in the other, and if we're standing on these two ends, how far are we now apart? All right. So Pythagorean theorem, okay, the formula that we use is a squared plus b squared equals c squared. Remember, where a and b are the legs. Legs make up the right angle. So this could be side A and this could be side B, or reversed. You can make this side A and this side B. It doesn't matter. But side C is always the longest side, always the hypotenuse. Let's plug in our numbers. So we said A is 12, so 12 squared, added on to B squared, so in this case, 5 squared. And we're trying to figure out that hypotenuse, that missing side here. We don't know it yet, so we'll just keep calling it C. Well, let's take 12 and square it. Remember, this is not 12 times 2. This is 12 times 12. 12 times 12 is 144. Let's add on. 5 times 5, not 5 times 2, but 5 times 5 is 25, and that's C squared. If I add 144 to 25, if I could talk, that is 169 equals C squared. Now remember, if we're talking about things with powers of 2, so I've got something to the second power, and I want to get rid of it, and I do, because I don't want to know C squared, I just want to know what C is. So remember, we use the inverse of a square root. So I'm going to take the square root of 169, I'm going to take the square root of C squared. Squares and square roots undo each other, so all I've got is side C, which is what I want. Now, if you don't know what the square root of 169 is, no worries, we can figure that out. Second, our x squared button, so there's square root of 169, and we get 13. So in this case, we know the distance here for hypotenuse is 13 miles. Let's try one that doesn't have such nice, neat numbers. All right, let's try it. Let's try the example. Let's turn our triangle too, because notice our triangle doesn't have to sit a certain way. The only thing we really need to focus on is the fact that it has a right angle. Okay, so let's let our right angle be up here this time. One side's going to be 7 centimeters, and the other side will be 13 centimeters. Okay, so remember, our formula for the Pythagorean theorem is a squared plus b squared is c squared. Remember, these are the legs. So maybe this is A, maybe this is B, and then our hypotenuse. And notice, I know this is the longest side because it's opposite that right angle. So that's C. So A in this case is 7, so 7 squared. B in this case is 13, so 13 squared. And we are trying to find that hypotenuse, so we'll still call it C. All right. 7 times 7, well, that's 49. 13 times 13, well, we just dealt with that in the last example, so that's 169. And we're still working, we don't know what C is yet. If I take 49 and add it to, what did we say that was, 169, I'm getting about 218. 218 equals C squared. Now remember, I want to find side C all on its own. I don't want C squared. And again, anytime we take something to a power of 2 and don't want that power of 2, we can undo it by taking a square root. So let's do that. I'm going to take the square root of 218, and I'm going to take the square root of C squared. Remember, squares and square roots, they undo each other, so we get C. Now, if you're having a hard time coming up with the square root of 218, there's a reason. 218 is not a perfect square number. Now, earlier in the year, we talked about ways to approximate this. We used the fraction method, and it's a fine method, but quite frankly, we don't have that kind of time anymore to sit there and figure out, well, what two perfect squares? We don't do that anymore. we're going to reach for a calculator like most people, okay? It's good to know a method for approximating, but for what we're going to do, calculator is going to be our friend. So second, our square root, we are looking at 218. Now, before you punch enter, you better have some idea of what you're going to get. So for example, I know that the square root of 196, which is kind of close to 218, is 14. So I know I'm going to get a number a little bit bigger than 14. I also know that the square root of 225 is 15, and that's pretty close, but we should still be under 15 as an answer. And notice in this case, we get 14.7648, blah, 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 who cares? Let's round it to the 10th position. So I'm going to look at the 7, go one position back. It's a 6, which means I'm going to round that 7 up. So we're going to get approximately 14.8 centimeters for our hypotenuse. So 14.8 centimeters. So what we're going to work on for the next few lessons is the Pythagorean theorem and indirect measurement. We're going to look at different situations, for example, like our pool scenario, where taking a direct measurement doesn't work. We're going to have to use indirect measurement to figure it out. And that's where the Pythagorean theorem, a squared plus b squared equals c squared, will come into play. We'll do more examples when I see you in class. Make sure that you're taking good notes, and I'll see you then, guys.